A black hole is a region of space-time where gravity is so strong that nothing, including light or other electromagnetic waves, has enough energy to escape it. The theory of general relativity predicts that a sufficiently compact mass can deform space-time to form a black hole. The boundary of no escape is called the event horizon. Although it has a great effect on the fate and circumstances of an object crossing it, it has no locally detectable features according to general relativity. In many ways, a black hole acts like an ideal black body, as it reflects no light. Black holes are physical objects in space, just like everything else we see in the night sky, but they pack so much mass into so small a space that not even light can escape their gravity. Black holes are scary for 3 reasons. If you fell into a black hole left over when a star died, you would be shredded. Also, the massive black holes seen at the center of all galaxies have insatiable appetites, and black holes are places where the laws of physics are obliterated. An observation of a black hole, which harbors 5 to 10 times the mass of the Sun and is located about 28,000 light-years from Earth, revealed it apparently pulled matter off a companion star, then spat some of it back out as gigantic bullets of gas moving at nearly a quarter the speed of light. The mysterious thing about the black hole is that the lighter outer layers are flung off into space, and the remaining core can create a black hole. A black hole has so much mass tightly packed into a small space that, close up, its gravity is so strong that nothing nearby can escape it. Carl Schwarzschild developed the idea for black holes from relativity's equations in 1916, just a year after Einstein published his theory. For this reason, early physicists studying these bizarre objects often called them frozen stars. Today, we know them by the name first used by Wheeler in 1967, the black holes. There are some speculations about the hotness or coldness of black holes. Stellar black holes are very cold. They have a temperature of nearly absolute zero, which is 0 Kelvin. Supermassive black holes are even colder. But a black hole's event horizon is incredibly hot. The gas being pulled rapidly into a black hole can reach millions of degrees. There are probably millions of black holes in the Milky Way alone, orbiting like the stars, but we cannot see them. Black holes are extremely dense pockets of matter, objects of such incredible mass and minuscule volume that they drastically warp the fabric of space-time. These monsters of the universe are nearly undetectable, unless they are feeding on space stuff or tugging on nearby stars. That means one hungry black hole could be zipping right through our solar system without us knowing, but that's highly unlikely. The most common black holes form from the result of a supernova. The catastrophic death of a massive star are stellar black holes. Most stellar mass black holes are roughly 5 to 10 times more massive than the Sun, but the NSF-supported Laser Interferometer Gravitational Wave Observatory has detected several with masses up to 100 times that of the Sun. Supermassive black holes are huge, ranging from millions to billions of times the mass of the Sun, and appear to be in the center of almost all galaxies. The supermassive black hole at the center of the Milky Way is LL, commonly known as Sagittarius A, with a mass of over 4 million suns. The NSF-supported Event Horizon Telescope captured the first image of a black hole called M87 in 2019, and its mass is the largest known, 6.5 billion times the mass of the Sun. In 2022, scientists released the second image ever captured of a black hole, the one at the center of the Milky Way dubbed Sagittarius A. To capture images of black holes, an international collaboration of scientists connected telescopes from around the planet into an array that worked together as a super telescope, enabling them to capture the region around the black hole and the pitch-black void at its heart, where the black hole lives. Astronomers have detected an impressive supermassive black hole devouring a star, and they've nicknamed it Scary Barbie, in part because of its terrifying power. Scientists called it one of the most luminous, energetic, long-lasting transient objects found lurking in a forgotten corner of the night sky. According to the Space Telescope Science Institute, approximately 1 out of every 1,000 stars is massive enough to become a black hole. Since the Milky Way contains over 100 billion stars, Our home galaxy must harbor some 100 million black holes. Though detecting black holes is a difficult task, and estimates from NASA suggest there could be as many as 10 million to a billion stellar black holes in the Milky Way. The closest black hole to Earth is dubbed the Unicorn and is situated approximately 1,500 light-years away. The nickname has a double meaning. Not only does the black hole candidate reside in the constellation Monoceros Unicorn, its incredibly low mass, about 3 times that of the Sun, makes it nearly one of a kind. If you fell into a black hole, theory has long suggested that gravity would stretch you out like spaghetti, though your death would come before you reach the singularity. But a 2012 study published in the journal Nature suggested that quantum effects would cause the event horizon to act much like a wall of fire, which would instantly burn you to death. Black holes don't suck. Suction is caused by pulling something into a vacuum, which the massive black hole definitely is not. Instead, objects fall into them just as they fall toward anything that exerts gravity, like the Earth. If a star passes too close to a black hole, the star can be torn apart. People must have a question about why we not capture black hole. Nothing can escape the massive gravitational pull of a black hole, not even light. Hence, there are no photons that are reflected, which can then be used to image the black hole as an object. It's called black holes for a reason, after all. That's not to say that we can't detect them. Astrophysicists use proxies like the stream of matter and energy pulled from a ripped-apart star, for instance. The gas molecules start swirling around the black hole in the form of a disk and emit powerful X-rays. Black holes can also be detected by watching for motions of stars near the black hole. This brings us to our next slide. For instance, a star thousands of times more massive than the Sun squeezed into a sphere approximately the diameter of New York City. The result is a very strong gravitational field from which nothing can escape, only a more massive black hole, but even then the latter would eat the former. At the very center of a black hole is the gravitational singularity. It's a one-dimensional point where a huge mass is squeezed into an infinitely small space. Density and gravity become infinite and the space-time curves infinitely. That's a lot of infinity, enough to make your head go dizzy. In fact, not even the laws of physics can stand that much infinity, apparently. As American physicist Kip Thorne puts it, the singularity is the point where all laws of physics break down. Near a black hole, the slowing of time is extreme. From the viewpoint of an observer outside the black hole, time stops. For example, an object falling into the hole would appear frozen in time at the edge of the hole. For more such videos, kindly like, subscribe, and share to my channel. We will be back with more interesting videos.